Okay, we are actually getting pretty close to the end of our space unit, but we still have a few other things that we need to talk about. One of those things is space and technology. Um, Obviously, astronauts have been going into space for many, many years, and they have to deal with conditions that are very different from the conditions that are here on Earth. Space is a near vacuum, there are extreme temperatures, there is microgravity, and so engineers have had to create technology in order to supplement for those differences so that astronauts could live and survive in space. Even though we can't see it, everything in everywhere around us, there is air. Um, and air, of course, we know are different gases dissolved in a nitrogen gas. But when you get into space, there is no air, and space is nearly a vacuum. It is almost completely empty of all matter. There are some stray atoms and molecules, floating around in space, uh, but it's but they're not close together. So it is mostly empty space between them. So because of that, because there is no oxygen in space, of course, spacecrafts have to be airtight. If the spacecraft happens to be in direct sunlight, it's going to reach extremely high temperatures. If a spacecraft were to be in a shadow, the temperatures would be very low. And so those spacecraft, in addition to having to be airtight, have to be insulated as well. Now, when astronauts are out in space, they experience weightlessness or microgravity. Remember, mass isn't something that changes, but weight would change because there is not weight, it's just a pull of gravity on us. So even though these astronauts are in microgravity, they are still under the influence just a bit of Earth's gravity. And that is what's keeping them in orbit so they don't fly off. They do feel weightless because they're falling through space with their spacecraft, but of course they don't hit because of inertia, which keeps them moving forward. Remember, we talked about inertia and gravity and how those two forces work together to keep objects in orbit. Okay, so the space program has led to many, many benefits. Lots of new technologies that have helped scientists work and a lot of consumer products that we actually use. Of course, when it comes to data collection and storage, large computers are needed to be developed to collect and store data from the probes that are all over our solar system. As scientists have collected those samples, they have to develop materials to keep those samples sterile. Um, we know that space science can require some very complicated calculations. It can be, really, it can be a hard thing to figure out the correct time to launch a rocket to reach its destination on schedule at the right angle with the proper speed. Um, to determine that launch window. And of course, computers have helped us do that. Oops. Telescopes that collect the light and radiation from outer space are used to help us measure distances. Lasers can be used to help take measurements. Astronauts on the moon set up mirrors, and we can fire lasers from Earth at those mirrors and determine the time it takes for that light to return. Space probes use radio signals to send back information. Um, and of course, we have websites that share that information. And one of the greatest forms of technology that we have gotten from the space program are what are called space spin-offs. These are items that were originally developed for use in space, but have since become consumer products. Joystick controllers, scratch-resistant lenses, freeze-dried foods, shock-absorbing helmets, shock-absorbing sneakers. All of those are materials that were developed by the space program that are now used by consumers. Lasers, pacemakers with long life batteries, So there's really a tremendous number of space technology things that were developed for space technology that are used in the consumer world. Okay, so what are some uses of all of those satellites? We know, and we saw in that movie Space Junk, that there are hundreds of things out there orbiting. They are relaying TV signals from one part of the planet to another. They are used for telephone signals. They are used for computer data, communication, collecting weather data, and other scientific data. We have observation satellites for tracking weather systems, for mapping the Earth's surface, for observing changes in Earth's environment. Now, specifically, most communication satellites are placed in geostationary orbit. And that means that the satellite orbits Earth at the same rate that Earth rotates. And so it stays over the same place all the time. All right, I hope that tells you a little bit more about some of the technology that has been developed for use in space. And of course, some of that has trickled down to us as consumers.